the calendar. I sent an email out to notify you guys of some due date changes, but just in case you didn't get it, here we are. This is today. We're gonna do a spatial patterns lab. It should be pretty short, hopefully. Y'all have homework 5 that was originally due today. It's due Friday. And then you have your story map outline, which was originally due Friday and is now due on Sunday night. So your story map outline lives here in your story maps section. Here's your outline. There is an example storyline outline. At this point, y'all remember that day that we had that really short lab? And I was like, here's a bunch of links for stuff that you can practice in terms of making a story map. And I'm sure everybody went and did it really quickly right after lab and we're focused. If just in case you didn't, now may be the time to go ahead and do those practice exercises so that you know how exactly, because it'll help you kind of visualize how your story map is going to look a little better. And just remembering, of course, next week on Tuesday, that is election day. If you didn't vote early, we don't have class that day. And so if you find yourself with some free time and you haven't done those practice exercises, that can be an opportunity to do it. But they are really, really helpful. I haven't required an assignment about it because I just don't want to grade anything else. But you guys, y'all should definitely try and work through them. Okay. Any, that's not right. Any questions about the calendar? Okay. So this brings me to my next point, which is homework 5. So in homework 5, you all will get to a point where you're going to have your sites for your survey data that you collected. They're probably going to be points, right? Maybe it's a transect, maybe you did a polygon or something like that. I think most of us, it should be points, right? And so you're going to go and you collect points. What many of you all will do, actually, let me see if I can do it as well real quick. So what many of y'all will do is you will go to your page with all your data and you're going to go to export your data and it's going to give you an option to export your data in a couple different formats. You can do KML, you can do a CSV, you can do a spreadsheet, right? Lots of different ways. So it'll look like this. So you go over to data and up here under export, you're going to have these options of what to do. And what a lot of folks will do is you all will go like, well, dang, I'm going to export it as a shapefile because this lady asked me for a shapefile. And clearly I'm just going to be able to do that. And then I'll have the shapefile and I can find it and I can just submit this. You can't. Because what you're going to do is when we, I'll just put in, spelling. Here, just let me get through this. Just let me get through this, you guys. I'm just pulling the data in really quick. And then you know what, while I'm here, I'll go ahead and do it like that too. So we can look at the CSV as well. Doesn't like to be rushed. Let's see. Let's see if it actually makes a difference. Let me look at the CSV before I go through all of this and do it. Let me make sure. Okay. So let's look at what the CSV looks like. And let's also look at what the shapefile looks like. Here's the shapefile. Here's the CSV. Okay. So when you get a, this is what I thought. So when you get a CSV, your CSV is going to look like this. It's going to have a species name. It's going to have, or whatever you did, right? Like whatever you did for your survey, it'll have over here. And so this was this, hang on, I'm lagging. I'm really slow, aren't I? Am I slow? Okay. I just all of a sudden will catch like a glimpse of my reflection and I'm like that creepy lady from The Ring, just like barely moving. But anyway, when you download it, you should get latitude and longitude data, right? You should have spatial data associated with your CSV. When you do this with, when you download the shapefile directly and you pull in the shapefile, it doesn't give that to you. You don't have a field that says X and you don't have a field that says Y. And this is a thing because it's ARC software talking to ARC software, it's trying to be like, I don't know, it's trying to like use less space or something like that. But basically, if you guys turn in something that looks like this, that doesn't have a column for X and a column for Y, or some geometry of some kind, you're going to get points taken off, like a few points taken off for your shapefile. And so you have two options. You can add a field here, right? And so that's a great option. You would just add a field. You add your longitude, you add your latitude. That's in here, great. And and do that by calculating your geometry in here. Or you can go the other way, right? And so we have this as a, so watch this. This is going to be, where am I? So these are the exact same data set. One of them is a shapefile. The shapefile that I downloaded from Survey 123 does not have an XY associated with it. The other data set is the CSV that I downloaded from Survey 123. And you're going to see how nice and different they're going to look. Oh my goodness. Oh, you know why? It's because I have it open. Close that. Gonna give her another second. Yeah, so that wasn't working. What am I doing? What am I doing? Oh no, I'm making a, what am I doing? Doing this. There we go. Do export, table to point. This should work because now it's closed. Great. Notice where you're putting it. Right. Remember, it's always trying to put stuff in these default geo databases, right? We don't want them there. They're hard to find. It's obnoxious. I'm going to name this survey GCS because remember the first time that you bring a data set over into ArcGIS, you only give it a geographic coordinate system. Don't give it a projected coordinate system. The settings are all sorted out. I'm gonna pull it over. These are going to be in basically the exact same place, but they will have different fields. So now we have X, now we have Y, now you have geometry, right? Same data sets, I just went in different steps. And so remembering always remember to never forget that there are about 1,000 different ways that you can do the same thing in ArcGIS, right? So remembering here, if you bring it over as a shapefile, you have to go in and you have to add that field. You would add longitude, you would add latitude. We did this in lab. I don't remember. What is it? Whichever one we did editing in, but we can go ahead and do this. Long. And I always make these float. I'm just going to leave that alone. I'm going to add lat. Float. Save your stuff. Show me my things. Show me my things. Save my stuff. Close my stuff. So now we have these fields. Right click, calculate geometry. And I'm not sure. I mean, it really, it's variable which one takes longer. It's just really like whatever you like, whatever works for you, works for your brain, works for me. But you can do it, but as long as when you turn the shapefile in, it is a shapefile that has a projected coordinate system, and it's a shapefile that has geometry. It has latitude, it has longitude. So actually look at this. When I created my field, I didn't set my settings for numeric, and it's actually not super precise. So when you do longitude, so actually let me do this. So when I do latitude, I'll go to calculate geometry. Oh, I can't because I already made that field. I wonder if there's anything I can do. I could just delete it and remake it. It's not a big deal because these numbers are in here. We just can't see them. So I was just going too fast, but you guys know what that's like, right? I'll just make a new one, show you what I did wrong, potentially. Add fields, add latitude, float. I'm going to tell it numeric, and I'm going to give it like 8 decimal places. Go up here, save. Close. Geometry. Latitude. Y coordinate. Decimal degrees. Run. Okay. So you could do it that way, or you can do it this way. You can go from a CSV to a shapefile, or you can do some editing on your shapefile. But either way, if you stop here, you're going to lose at least a point because this data set still does not have a projection, right? It just has a geographic coordinate system. So you have to take that next step and export this data with the correct projected coordinate system. And remember that we're in here and we're like WGS 1984, zone 15 all day long, but that's because of where we are, right? Anywhere else that you are, a lot of y'all, when you turned in your map assignments, you gave it a projected coordinate system. You gave it this projected coordinate system, but you wouldn't use that if you were working somewhere else. It's okay. It's not a big, and I didn't take off for it, but this is how you get the data into that projected coordinate system. So, actually, I'm just going to stop there. It's worth it to mention because we have been talking about how there are many, many different ways to do things. There's a tool, that can transform your, geographic transfer. You can basically, it's another way that you can reassign a geographic coordinate system or a projected coordinate system. So define projection, calculate projection, project spatial data, right? These are all these different ways to do stuff. The way that we do it is we just make a copy, right? So you can actually like run a tool on, and the reason I'll tell you why I don't like doing this is because you're just running a tool on your data. And then if you mess up, which is really, really easy to do, especially for these transformations and project tools, if you mess up, then you have messed up your original data set. Like, and which is pretty hard to come back from. And you just have to go all the way back to the beginning and like re-download it. So that's why I have us do it this way, where we go to data, we go to export, we assign it the coordinate system that we need, and we move forward. Okay. So you're going to be turning in 3 shape files for this homework 5. It's going to be your data set, this stuff. It's going to be my route as a shape file, and it's going to be your route as a shape file. All of those things should have geometry with it. And that means like, how long is the route? Where are your sites? Blah, 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 stuff like that. Okay. So don't skip those steps. Let's all get 100% on these homeworks. I'm about ready to grade homework number 4, which is find a job. I expect 100% on all of those. If you guys tried, you should be fine. And so I'll put those grades in pretty soon. Okay. Does anybody have any questions about the homework assignment or the story map outline or map assignment 2 or the calendar or anything here?
So for the homework, it's you make the survey, you populate the survey with data, then you grab that data and then pull it into to do all of that and then make it a shape file. And then it's also the routes, or is there also a separate shape file for the sites, or is that included in the routes shape file?
You're going to have 3 separate shape files. So you have so I didn't give you guys a shape file, provided you with a KML. And so you have to remember how to convert that KML to a shape file. So making you guys remember how to do that, because that's going to come up again. And then, so there's my route. That's like the transect essentially that I'm sending you all along. There's your route, which is how you get there from the R&R building. And then there are the sites, which are like, I expect point data from y'all. I wouldn't expect transect data or polygons or anything like that. So I think the workflow that you described, Carl, is accurate, but it is those three shape files and your map.
Okay, I was confused because I thought when you meant sites, I thought you meant you make additional sites around that area,
You do. Yeah, you totally do. Yeah, that
but
is.
like areas, not like the point data is what I was thinking of.
What do you, I don't
Like
understand.
what I did was I didn't submit this because I wasn't completely done, where I went on Google Maps and did a polygon of separate predefined sites around the lake. And
Not on my route.
well, it was near the route for
That's
some of
fine.
I don't know.
That's
I
probably
I
okay.
it was
I think you
confusing.
probably, I suspect you may have overthought it a tiny little bit. Just a teeny tiny little bit. But yeah, I basically just wanted you guys to be able to figure out where I wanted you to go, get there, go for a walk outside. Was my primary point, was to get you guys to go outside and use survey 1, 2, 3. go for a walk outside and create new sites, and just so that you have data right on that point. Like I'm trying to fabricate an experimental design in the field. So I think that's fine, but we can hop offline and we can share a screen and look at it if you want to, if you're worried that you're not doing it right.
Okay, yeah, no, I think I get it now. It's just I confused myself with it a lot. But yeah, no, I already made your thing from a KML to a shapefile,
Mhm.
and then I was attempting to make it very complicated for myself, but that really helped.
I I support you. I support you in all of these things. Let me see if I can find mine really quick. I don't think this is it. I don't think this is it, but maybe it is. No, that's not it. Um, that's not it. Okay, yeah, I was trying to figure out a quick way. I think you're okay, but basically y'all will have like do 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 y'all will have a little you should have a map that has a route, the little route that I made where you're like walking walking walking, and then it'll have a route that you guys made somewhere over here walking walking walking, and then you'll have points along my route that I made for you. Okay, but yeah, if anybody's confused, we can sort it out later. You are doing both of those things, Taylor. You are drawing your own route and you are showing my route as well. So it's basically, yeah, so you've got to draw your own route and remember what I've said about making routes. You don't want to do it in Arc. You want to make your own route in Google and Google Earth. So this requires you all to go back and forth from Google Earth. Like I think most of y'all probably pulled this up and you're like, oh, I know exactly where this is. And you didn't necessarily need to pull up field maps, but it's a great idea to do it, to pull up field maps and to try to make sure that you understand how to do field maps. So remembering, the way that you get something from ArcPro into field maps is you have to take it from ArcPro and then upload it into your content in ArcGIS Online, and then that's a map, and then you make a map out of it. And so then you would like go to where you want to go on your phone, on your map, and then you'd have your survey already made, and you'd be like boop 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 boop, collect your data, draw your little route on Google Earth, and then just make your map. So this is a workflow. You're getting into the weeds of workflow, right? So if it doesn't work well under pressure and if you're stressed out. So just try to so if you find yourself, slamming your head against a wall with any of these assignments, particularly this assignment and map assignment 2, take a break, come back to it later, shoot me an email. Okay. Okay. Any more questions about this? Okay. Okay. So everybody knows what they have coming up. Okay. All right. So today is our first day that we are going to do anything with raster data. So what we've been working with up until this point is vector data. So vector data are our shape files. Vector data are homogeneous shapes across the landscape. So a bunch of polygons, a bunch of lines, a bunch of points, something like that. Raster data is not quite the same thing, right? Raster data lets you represent a contiguous surface. And so we're going to play around with that a little bit today and see how that works. So this is some overhold from Dr. Long, right? And this is something that I want you all to think about when you're doing your story map outline is this slide, right? Your story map outline. Clearly, your assignment is to your topic is a conservation issue, right? make sure that it is a conservation issue, right? That it's not just like biology of the Louisiana pine snake or like number of cats or something like that, right? Like what is the issue? How is this a conservation issue? Make that immediately clear by the title of your project. You need to identify what data you need, what data you have. Really, when you're thinking about this, is you're like, what do I need my attribute table to look like? And that's something that I really want to make abundantly clear with this assignment as well, is because a lot of y'all are going to be going out and you're going to be getting data, and the data is going to be really cool in theory, but your attribute table is not going to be in a format that you can work with. Like, right, it's just going to, the data format matters so much. And so this is something that unfortunately I don't have the time to teach all in this class, but if you ever get an opportunity to take an R class, you're not going to want to do it, and it's going to be hard. It'll be at least as hard as this in the beginning and maybe a little bit harder because it can be really foreign to us, but please take it. Please take it, because that tells you how to manipulate your data and to get your data in the format that you need. Which, if I'm being perfectly honest with y'all, that is like 40% of science. It's just like getting it's data management and getting it into the right format that you need. It's like it's not super glamorous, but if it's not in the right format, you can't do it. Um, so really thinking about that. And if you, particularly, most of the time at this stage, when what y'all are learning is you'll get to that point where you're like, oh my gosh, I have this stuff and it's so great. I'm so excited. And then you're trying to do any type of spatial analysis with it. And it's not working. A lot of times it's because your data is not in the right format. So think about it, come back to it if you need to. Okay. So identifying spatial patterns, right? Spatial patterns, patterns analysis. This is one of the reasons why ArcGIS and spatial, spatial mapping is so useful for everybody, right? Because when you can visualize, and this brings the art part into it, is when you can visualize trends in populations or trends in environmental conditions or characteristics or something like that, you can start to ask the right questions, and you can start to develop appropriate monitoring and methods to answer these questions. And I mean, really, like thinking about, I know a couple of you are in my 2101 class, or at least you've had it before, is like the definition of ecology is exploring patterns, like relationships between species and their environment and vice versa, right? How the habitat modifies species populations and how species populations modify their habitat, how those patterns translate across space and time. So this can help us find gradients, like diversity gradients, so species diversity gradients. So we see declining species diversity with increasing stress. This can help us identify patches, so you can find areas of more dense populations of organisms. It could be patches of, suitable habitat or something like that. And it can help us identify, like if we get something that makes no sense, we're like, okay, I'm not collecting the right data, or I'm not looking at this the right way. This is the first step that many of us have to take to fully understand our system, our species, whatever we're looking at, right? Is we have to look at it to be able to understand what is going on. And so this is kind of a fun example that Dr. Long came up with for everybody, right? And so this is an example of monitoring the spread of an infectious disease by mad rabbits. And so this is actually a good example of how you would monitor the spread of an invasive organism. Something like the lanternfly, something like gypsy moth, something like water hyacinth, whatever, right? This is how you would monitor the spread of organisms, how you would model it, right? And so, but these data that I'm going to be providing you for this lab exercise are in this like super sweet, perfect format. And so you're gonna, a lot of you that have a species in mind for your story map, you're gonna be like, oh, this is gonna be so rad. I'm gonna be able to do this with my possums, or I'm going to do this with my snow leopards, or whatever you're going to do it with. But notice the format, because it's very specific, right? And these it matters. So what we're going to do, this is what wildlife managers and wildlife biologists do, is they create something called minimum convex polygons. And they create these minimum convex polygons to assess the range of organisms. And so basically what you do is, it looks a lot like our bird points data that we've worked with a couple times, where you're like, I saw birds here. This is my range of birds for this particular area. And so what it does is it uses presence data to create a range map, essentially. And then the second part of this lab is looking at patterns. That's going to give us not only a range map and outline, but it's going to give us like a density of organisms that we can look at as well. And it looks something like this. So what you do, and what the tool does, is if you have points, if you have lines, if you have polygons, it's going to create, we're going to use this convex hull. It's going to create a polygon that fully encompasses your points without you having to draw it on. We did that once when we drew a shapefile around our bird points. We drew our own polygon, but there was some error in there. And this is just a super quick way that ARC will do it for you. So let's do our thing. Let's go to Moodle. Let's download our data if you haven't already. That's the lab. These are the data. Hopefully everybody's already made a folder for this class. I actually haven't, so maybe you're with me. I'm gonna go ahead and make my folder. Six. And in lab 6, I'm gonna put the spatial patterns data in there. And then I'm gonna unzip it. Whoops. Okay. So this looks pretty normal. We have the same prefix, and then different file extensions. So we have something called United States counties, we have outline, we have points. I'm expecting to see 3 sheet files when I connect my folder in ArcPro to this. So I'm going to go ahead and turn this stuff off. I'm actually already connected to my I'm just connected to all of R&R 3004, but we can do this together. I'm going to right click, add a folder connection, just so it's a little bit easier to navigate to. And I'm going to connect to today's folder. And indeed, I do have 3 shapefiles. 3 shapefiles to play with. Okay, and then what are we doing now? We're doing something. Okay, I'm gonna move this whole thing over, guys. Yeah, so I can read it and do it. Okay. So we have United States counties, United States points, United States months. Let's pull over our United States outline. And I was zoomed in to the survey points, so okay. Let's pull over our United States points and put that on top, maybe. Okay, So I have two data sets that were provided to me by somebody that I don't know. So the first thing that we need to do is we need to look at their spatial reference. So let's check out points, go to properties, spatial reference. Okay, she has a projected coordinate system. This is NAD 83. She has which all projected coordinate systems have a geographic coordinate system. So we have NAD 83 and we have NAD 83 contiguous USA Albers. So let's close that and let's check out United States outline. Let's see what projection she's in. She does not have a projected coordinate system, but she has the same geographic coordinate system that the points do. So let's go ahead and make this work. We're going to go ahead and we're going to give this a projected coordinate system, and we're going to give it the same projected coordinate system as the United States points. And so remembering that you could do this by actually operating on this data set, right? You would use the tool in geoprocessing. Again, I really don't like that because then you mess with your original data set. I always make copies of everything. So the way that we do this is we go here, right click. Y'all, this should be old hat at this point. Hopefully it's getting easier and you don't have to look it up anymore. You right click, cruise on down to data, cruise on down to export, output feature class, always check and see where it's going. Okay, mine's going into homework, so I don't want it in homework. I want it in that lab 6 folder in here. So I'm going to name this USA outline PCS. And then under environments, I'm going to give it the same coordinate system as the points. Because those points, we went and looked. They have a projected coordinate system ready to rock, right? So I could navigate to that via the sphere and find it. But since I already have that data set with a projection in here, it's something we know and love, NAD 83. It's ready to go. We're doing great, right? And just go to OK. All right. And so now we have two things that look identical, right? But one of them has a projected coordinate system and one of them does not. So I'm going to go ahead and remove this United States outline from my map. I'm going to go ahead and remove this survey GCS too, just because that was just as an example. Okay. So, and if you all, in the lab for today, we get a little bit into this. There are lots of different ways to do the same thing. Okay, loads and loads of different ways to do the same thing. Again, I always make copies. That's the way that my workflow works. But if we don't learn anything else from this class except this, just know that everybody's brains work very differently. Okay, so let's fool around with symbology a little bit for this USA outline. I'm just going to make her hollow. I'm going to give her I'm just looking at stuff really. I give her like a red outline. Is that what I want? Sure. I don't know. I don't care. I'm gonna give her. I'm gonna leave her alone. I'm gonna leave her alone. She's fine. She's got an outline. I can see where it is. I could make it like a little thicker. Oh, that's fine. Okay. So now my points, my US points are already in red. Remember, there's a lot of different ways to do this. You can right index finger click directly on the point, right? And that pulls it up. You can right click and go to symbology. You can select your data and then open up symbology over here. So many different ways to do the same thing. But I'm just going to change the color to a super bright red, and they make them really pop. Make them really pop. Okay. So now we have two data sets on our map that are looking good. We can see everything. The outline is clear, right? So if I were turning this in, I might have a picture of this map, and then I might have a zoomed in image of the points, right? Something like that. Okay. So now we're going to go to our geoprocessing tab, right? And so mine is already open down here, but remember, if your geoprocessing tab isn't open, you just go to analysis up on the ribbon, and then you're going to click tools. That's going to bring you over here to this geoprocessing pane. Nope. Don't want to calculate fields. And it automatically directs you to these favorites. We're going to go to toolboxes. And in here, we are going into data management tools. So they're in alphabetical order. You're going to go to data management tools, and we're going to scooch down to features. And lots and lots and lots of different options in here there that you will find necessary maybe at some point, right? These are so specifically tailored to, depending on what you want to do. But the one that we're going to use in here is we went features, and we're going to go to this minimum bounding geometry. And that's our minimum cost, that's our minimum convex hull, minimum convex polygon. That's right. This is going to create our polygon around these points. That takes up the smallest amount of space possible. So our input features, we're going to select these United States points. Our output feature class, it's going to try to put it somewhere funky. Actually, mine is figured out where I want it, and mine's putting it in this lab 6. I'm going to name these US MCP month 1. All right, minimum convex polygon. Geometry type, it says rectangle by area. We want convex hull. So we're going to select that. Group option, we're just gonna, it doesn't need to do anything. So it could be none, or it could be all, right? So actually it has to be all. So we'll just leave it in this all. Environments, we could check, but we don't really have to mess with it. Remember, environments are primarily for assigning the coordinate system. At this point, when we get to lab 7, we'll be using the environments to do some masking. Which will make sense later, but we're not going to do that right now. So anyway, this is all fine. Ready to go. Run. Okay. You should have this sweet little baby polygon. And ARC is trying to be helpful. And so it noticed that it puts the polygon below the points. Right, anytime that you make a polygon and there are point data, it's going to try to put the polygon below points. But I know a couple of y'all had little tiny baby freakouts when you would pull your points over and you put them like here, right? And you're like, they're not showing up on my map, and it's just because it's buried below your base map. It just has to go to the top, so it's there. But all of this, it's gonna be so much better for you if the next time you try to do this, if you remember some of it. I know this is the point in the semester, I know, where everybody's starting to kind of crack, but you're doing so good. Just keep going, and just remember to pull your points to the top. Okay, so now we have our little polygon. Right, this is cool. This is helpful. Especially if we wanted to define like a range or something like that. So we were like, okay, we've got these mad rabbits and they're attacking people's faces, and it's like 28 days later, but with rabbits, right? Zombie rabbits basically is what's going on. And we're looking at this polygon of where they are, but what we really want to know is like, where are they going to be? And what is the spread going to be like based on what we know about this organism? Um, this is why many students out of this program end up doing something that works with invasive species, because invasive species are a big concern, of ours in this day and age. And there's a lot of money in eradicating and controlling invasive species. And so we know a lot about their spread and their dispersal and things like that. So, we have points here and we can see, we're looking at this and sort of like qualitatively, we're looking at this and we're like, yeah, there seems to be like more rabbit attacks like right here, and then there are fewer out at the edges. But maybe there's definitely a better way that we can visualize this. And so this is with something called kernel density estimates. And so kernel density estimates basically will give you the probability of the density of your organism given some variable, right? And so what we can do is we can basically come up with a way that will show the density. It kind of looks like a heat map, right? And so if you're looking at like a weather map, and areas that are really, really hot, or areas that are in like a drought, or areas with like extreme something, you'll see like a darker colors in the middle, and then it gets lighter as it goes away. This is kind of what we end up making here with these kernel density estimates. And so these allow us to identify hotspots of occurrence, hotspots of, and so really maybe what we're looking at, when we're looking at that iNaturalist GBIF data, is like maybe we're really looking at like hotspots of use of iNaturalist as opposed to necessarily like hotspots of actual species presence, right? So kernel density estimates pretty cool, and they can give us good information like that. If you have your data in the right format. Oh, and so I have an example. So this is kind of what it looks like your hotspots. And so usually when we see something like this, a map of density estimates that's published, we usually have something that looks like this. It's pretty, it's got this density of points, it's got smooth lines, it's a raster that was created at some resolution, but they all kind of start like this. Because remember, rasters are operating on a grid. And so basically it's like your resolution and your grid size. Are we looking at a 5 by 5 meter pixel? Or are we looking at a 50 by 50 meter? Are we looking at 500 by 500? The software will run whatever you tell it to in terms of resolution, but it all depends on the input data, right? If you have good input data, and your input data are at a resolution that's high enough to represent that output data, then you're okay. But a lot of people, without the technical expertise, can run these tools and they can say, oh, well, I got this down to a resolution of 1 meter by 1 meter. But if their input data was 100 by 100, it's absolutely useless. Okay, so we're gonna do kernel density estimates instead of these minimum convex polygons. Okay, so now what we're gonna do is we're gonna pull in our third data set in the spatial patterns folder. So hopping back over to ArcPro, and we're gonna pull over this United States counties shapefile. And so this is giving us county data, right? And so let's look at her and just check her projection. She doesn't have one, so let's do that. First things first, let's keep it organized. Right click, data, export. Where's she going? All right, US, counties, PCS, save, environments. I'm able to select from my points because I know that what I have on here has my correct projection. Okay. Remember, now we're doing analysis. Projection really, really matters. We're going beyond just looking at the stuff on a map and just being able to get it to show up in the right place, right? We're doing analysis at this point. Okay, so now we have US counties PCS, we have US counties original. Let's remove this original from our map so that we don't mess with it. Okay, all right. So now we have everything in the same coordinate system. All right. United States hollow. Let's make these counties red as well. Okay, let's save our maps. And let's look at our attribute table. So we're going to go over to US counties PCS. Okay. So what we have here is United States counties without geometry, I might add. But that's okay for this particular assignment. That's okay. We have about 3,000 rows of data. And for each of those rows of data, we have 1, 2, 3, 4, 5, 6 different time steps. This is the format that your data need to be in order to run this kind of analysis, right? So what we have here is basically you're looking at number of occurrences over time. And so this county, whatever it is, month 1, 2, 3, 4, 0, right? It is spreading very, very quickly. To represent something like the spread of a disease like COVID-19, right? This is exactly so GIS goes far beyond natural resource applications. It's remember, spatial analysis started with epidemiology, with trying to understand how quickly and how disease was spread. It was looking at cholera outbreaks, right? So this is absolutely critical types of analysis to do in the field of disease spread, right? And so it's just thinking about all of your different applications for GIS. You can let's say that a new weird dog flu shows up. Like maybe you're going to be the veterinarian that's able to actually provide, GIS data to something like that. Let's say that there's a new parasite. Remember there was like that weird parasite that was like infecting elephant brains a little while ago. It was like a weird thing that was going on. There every field, like I'm trying to think of anything that doesn't have like GIS applications, and there really aren't very many. But somebody worked really hard to get the data in this format the way that it is, right? Or they knew a lot about coding and were able to just like type in a couple lines of code and get it to work, which they worked really, really hard to figure that out. Okay, so what we're going to do is we're going to create these kernel density estimates for these different time periods. So what we're doing for the first time is we are actually going to take point data, feature class data, vector data, these counties with these numbers associated with them, and we are going to make a raster out of it. We're going to take something that's just all it is this contiguous surface, and it's going to have this is the only variable it's measuring is number of something, right? And so we'll go over to geoprocessing. We're going to go back up to our toolbox. Okay, and we might actually have to do a couple of things here. So we're going to be using spatial analyst tools. Oh my gosh. And if I can't remember how to do this, it's going to make me crazy. We're going to go into spatial analyst tools, and we're going to hope that it unlocks for everybody. But if it doesn't, like, does everybody's under spatial analyst look like mine, or does yours have like a different thing on it? Like a freaking out.
Mine looks like that.
Okay. Some people's might be well, just you'll know who you are in a second if it looks terrible. So we're going to go into spatial analyst, we're going to expand under density, and we're going to go to kernel density. Everybody still with me?
No, my tool is not licensed.
Okay. So you go to project. You're going to go add-in manager. Is it options? Licensing. Might just be licensing. It might just be go to licensing and go to, I don't know if it's, let's try manage your data licensing. Maybe. And you might have to give it a minute and then there's going to be stuff that should pop up. It might not be this. Configure. It might be configure. See how she's spinning? I have this in like my emails from last semester, but no, it's not this. Hang on one second. Hang on one second. Hang on one second. No. Okay, hang on. I remember how to do this. Hang on. Okay, let me just search through my emails real quick.
I fixed it.
Oh, you did? You got it?
I did, but I can't share my screen, but I don't know if anyone else is having the problem. But I just checked off spatial analysis licensing.
Yeah, that's what it should look like. Yeah, so it should, something like this, but there should be like a box that you just go boop and you just say, yep, I'm turning it on. That should be that simple. Okay. I did you see? I was like, oh, I said it's easier. Yeah, like, okay, good. I'm glad. So everybody's okay. Everybody has spatial analyst. Okay, I'm so glad that you found that and didn't have to wait on me. Good. Okay. So are we all here under kernel density? If you're not here, speak now or forever hold your peace. Okay. Super duper. All right. So input point or polyline features. We're pulling in that United States counties, PCS. Population field, we're going to select month 1. So what this is going to do is this is going to create a raster that shows the number. So remember that month 1 is just a number. It's either 0 or it's between 0 and something else, right? And so we are representing month 1 at this point. All right, Jacob, just keep going. Keep going. We're gonna do this for each of these months. So this will be repetitive, right? Spatial analyst tools, density, kernel density estimates. Month 1, output raster. Where does she live? She's gonna live in this lab 6. And notice nothing else in here is a raster. So nothing, we're not seeing anything else. Then, although we've made a bunch of shape files and we put shape files in here already, right? So we're making a raster. Let's name this month 1. Save. And then check this out. Output cell size. It's defaulting this massive output cell size. Just based on like the size of, of something. Honestly, I don't know. And it's almost where we want it, but let's just make it a nice even number. Let's make this 100,000. 100, 1, 2, 3, 4. Okay, six zeros. I struggle with this so much. Area units. Oh, search radius. Let's do search radius. Also 100,000. Our area units, let's do square meters. Output cell values, these are going to be densities, so we can leave that as density. Method planar, we can leave that as planar. Input barrier features, we're not going to touch that today. We're going to leave that alone until we get to lab 7. But this input barrier features is an incredibly helpful tool that we haven't had for a super long time with ArcGIS. We used to have to do a bunch of crazy stuff to get it to work. But basically, like, we're going to use it next time for like trying to interpolate salinity. And so basically it's trying to create a smooth surface for some contiguous variable. But like if there's a road or a levee there, that's a big barrier. And so let's say that you were trying to like look at migration paths for organisms or something like that. And you were like, I know that this organism cannot get over a highway that's this big. That could be your barrier features or something like that. But we don't need to touch that right now. So we're just going to let everything go. Oh, thank you. Okay. Output cell size, search radius, densities, barrier features. Let's go to environments. Output coordinate system. We're going to make sure that it's the same. Doesn't matter. These are all the same, so it doesn't matter. They should be all good. Now, the one thing that we're doing that's different is we're going to go down to extent. We're telling this tool that we want it to run across the entire outlet, this whole polygon of the United States, right? And so so if we didn't select this extent, what we would get is we would get a rectangle that was like really big. And it wasn't just, it's not like cut out to the image of the United States, right? So we want to go ahead and set this extent, right? We're going to do the same as layer of that USA outline. And then we're going to go to run.
Wait, mine doesn't look like that.
Yeah.
I think we all have different extents.
Out, everybody freak out. That's it, wherever your extent is. So your extent might not look exactly like mine, but you will have an option that says extent. And you are just going to pick you're going to pick US outline. Okay?
So mine says X and Y extent, and then you drop it down and it says top, left, right, bottom with zeros that you can enter. And then it says extent coordinate system. And then,
show me your screen. Show me your screen.
okay, yeah, that's easier.
I mean, there should be a ribbon and there should be something that says there, that's the third one from the left that says set as layer, and you just do it from there.
It might look a little bit different, but the language will be similar. It'll say something like, yeah, there'll be some language that says extent.
Okay, wait, what was it? What did you say?
Right there, extent.
Yeah, the third from the left, the one, the folder with the drop down and the ribbon. Yeah, click on that.
Yep.
And then you just do the outline.
Yep.
Oh, okay, okay.
Yep.
Oh, okay.
And then go to run. You should be ready to go. Yeah.
Did it do it?
It's doing it.
Oh, it's loading down here. I can't see because the little Zoom thingy is in the way.
No, it looks okay. It looks okay. Okay. Oh, I'm gonna sneeze.
Okay, I'll stop sharing my screen and hopefully it'll work because it's taking forever.
Yeah, it takes a sec. So rasters take longer, right? It takes longer, but it shouldn't.
Oh, okay, wait, it worked.
It shouldn't. Yeah,
Wait.
everybody on track. Are we all here?
Yes.
Should I go over here? Oh God, I need like a curtain, something, because this is only going to get worse next week because the time changes. Okay, so you probably can't see too much, but wait, let's leave that there. I'm just going to turn these off. I'm just turning off US counties. I'm turning off months. I'm turning off everything except for the outline and this new raster file that I got, right? So I have this new file that's giving me course scale density estimates in month 1, right? And so this is creating this is creating a cool kernel density estimate, but let's zoom into that. And so this doesn't look great because I want it to just be like perfectly clipped to the edge of this outline, right? And that's usually what you want. You don't want, this just looks messy, right? And so there are, again, many different ways that we can do stuff like this, but for right now, what we're going to do is we are going to do something, we're going to use a tool called extraction. So you're going to go back over to your geoprocessing pane, you're going to back it out. We're still over here under spatial analyst because we are working with raster data. Anytime you're working with raster data, you're mostly going to be living in the spatial analyst section. And we're going to hop down to extraction. And so for extraction, we're going to go extract by mask. And what this is doing is this is just clipping our density estimate to this outline, right? We told it to process all the way to the edge of the United States outline, but check this out. Right? So it's basically, it's processing here to here, it's processing here to here. It has to make these grids, it has to make these pixels. And so what we're going to do is to clean this up on the back end, we're going to do, we're going to extract. Okay. Nope. Mine was 100,000, 100,000. All that stuff. But it's we've got a couple more things to do, so don't worry about it too much. Don't worry about it too much yet. Okay, so we're gonna go extract by mask. Input raster. I only have one raster here, so I can easily pick that out from the dropdown. Feature or mask data, that's going to be the USA outline. Output raster. We are going to name this month 1 mask. Go save. Oh, where is it putting it? Are you putting it in the right place? I think it was in the right place. We'll find out. Let me just get through this and I'll try to figure out what's going on with you, Stephen. What am I doing? What am I doing? Extraction area, inside. Yeah, we'll do inside as specified below. It's fine. This should all be fine. Let's go. Let's click OK.
I have a question about just like the data.
Mm-hmm.
So you said that there's a lot of coding in order for it to get to like month 1 to month 6 like this, but isn't it an example of like if a dog had a puppy every month and every month it had exactly 2 puppies, wouldn't you be able to just like do the math in a calculator to get like the projected month in the future and then like add it in into Excel?
Sure. Yeah.
Oh, okay, slay.
But when you have 3,000 rows of data, it's pretty wild. And it has to be in this format. To run this particular analysis, it has to be like something and then month, you know, right? It has to be in that, like in this format.
And is the model just randomly placing those dots somewhere or?
Nope. Those are the like capitals of or counties. I think those are like the center of all the counties of the state or something like that.
Oh, okay.
So yeah, these are real names of real counties that have like real data. Nicholas, I can't really follow your flow of questions. I don't really know what you're asking.
All I'm saying is,
do you want to share your screen?
Yeah, that's fine. Can you see this?
Mm-hmm.
Do you have those big purple squares? Mine's only this small area.
Is it because you're ahead of me?
No, this was what you did. You did the month 1 raster, right? The kernel thing.
Mm-hmm.
And it was square kilometers, right? Square kilometers.
Square meters.
Square meters.
Mm-hmm.
That's all I needed. That's what I was asking.
Yeah, okay.
And then you said 100. What am I supposed to put 100,000 in?
Not for this tool. That's for the density tool. Yep. So it's 100,000 in output cell size and 100,000 in the search radius as well.
Gotcha. Okay. That is all I needed then.
And you should be all set.
All right. Thank you.
No problem. Okay. Okay. Dooba-dooba-doop. Dooba-dooba-doop. Okay. So now, so when you pull in raster data, it like you have to fool around with the symbology a bit, right, to make it work. So what I'm going to do is I'm going to go in to symbology. Oh wait, so let's zoom out. Hang on a second, let me show. So everybody's probably looks like this, but now we have it's clipped it to the edge as best as it can. It's a little messy, but it, you know, it basically works as much as it is as best as it can. Now what we're going to do to make this look better is we're going to do something. We're going to stretch the symbology. So primary symbology, it's stretched. We are going to switch our color ramp so that it goes from white to black, right? You could also just go here and click, boop, invert, and then it's going to shift that around, and that looks much nicer. Stretch type, this is doing it right now. It's doing something called percent clip. We are going to go down to minimum and maximum. There we go. There we go. Okay. And so now everybody should approximately look like this, right? So we changed a couple things with the symbology. I inverted the symbology that it assigned, but if you select the drop down, we have lots of different options, right? You can make it colorful, you can make it black and white, you can make it more chunky, you can make it blue, and then, you know, lots and lots of different things that you can do depending on what you're trying to show, right? And so I'm just doing black and white, where the darker colors represent higher densities of outbreaks, and the lighter colors represent 0 to less. And so all we would do is we would do this for every month, right? And so we'll go back over to geoprocessing. And so remember, there's 2 steps to this. We go up to density, we do our kernel density, counties, population field, this time it's month 2, output raster, this is month 2, output cell size, 100,000, search, 100,000, area units, square meters, output cell density, cell values or densities, method is planar, barrier features, environments is set. So output coordinate system, you can select anything. Extent, processing extent, remember that's where everybody's looked a little bit different. You just want to make sure that it goes to the United States outline. And I think I've tried this before. So one thing I want to mention really quick is everybody just pause with your clicking. If you're playing around over here in environments, or if you're looking at it, which I know some of y'all are, we have a couple of different things going on. So we set our processing extent, and then we have this thing called parallel processing, which we don't need to worry about, and then we have this thing called raster analysis, which we don't worry about today, but we have this mask option right here. And this mask option sometimes works, where you can set the mask now, right? We could mask it to that outline, but sometimes it doesn't. And it's just like a funny thing where sometimes you have to go through the steps to do it. And if I remember correctly, this is one data set where we do have to go through the steps to do it. Like I can't just select mask and skip the step that we have to go through next, the extraction step. We kind of have to build the raster first and then take the cookie cutter, you know, and extract it. So I just, but there are some formats of raster data where this will actually work, and we'll play around with that. So I'm just going to go to run. And it's making a raster, so it's making over the entire United States, so it will take a little bit longer. And you can see, right, if we were just looking at the purple data, right, month 1 versus month 2, you should start seeing it spread, right? And so now we're going to make it pretty, or we're going to make it match. We're going to go down to extraction, extract by mask, input raster, month 2, mask data, USA outline, output raster, month 2, mask. And I think that's it. I don't think we have to do anything with environments. I think we just go to run. About to find out. Yep. And then symbology here. It's on stretch already. I'm going to go to invert. And then we go minimum, maximum. And now we can compare the spread between month 1 and month 2, right? So whatever this is, spreading, right? And we're getting this contiguous data set across the United States. Let's go ahead and do one more month. So hopping back, scooching up to kernel density, counties, month 3, 100,000, square meters, densities, environments. Dense. Okay. Have some of these weirdos showing up in Florida. Okay, and so now we've got to do that extract by mask. Oh, dang it. Look at what a stupid name I gave this. I don't even know where I put her either. Oh, wait. Mask I have. Output raster. What happens when you try to hurry? 3 mask. Okay, symbology, invert, minimum, maximum. So there are so many times where what I have to do, and what you all will have to do if you develop any technical proficiency in this whatsoever, is you're going to be in a meeting with people, and a lot of it is going to be you guys poring over something that looks like this and just going, you know, looking around, cruising around, seeing how it's spread, you know, like things like this. So it's really, really helpful to have these different time steps. So something that you can think about for your story map is like, I know maybe some of you are looking at the spread of invasive species. Maybe some of you are looking at loss of some particular habitat. Maybe some of you are looking at some other habitat condition that you're measuring. If you can get your data in a format that looks like this, right, where you have something and then you have time period 1, 2, 3, 4, 5. This can be a really cool way to show the spread of organisms, to show the decline of organisms, something like this. But you have to have, it has to be a very simple but very elegantly designed data set. So as Taylor was asking earlier, she was like, well, if you know the reproductive rate of this organism, can't you just pop it in? And the answer is absolutely you can. But it's like, imagine if you were trying to look at multiple months, at multiple years, at a large area. It's a very simple data set, but it can get very cumbersome very quick. And it's like, and if you're collecting data from a bunch of different sources, it can just be like total bananas. All right. And we don't want total bananas. We want it to be elegant and nice and like well put in. Okay. So that's that. That's lab for today. Thinking about data format and think about yourself, and yourself, and just, would you rather manipulate your data in a spreadsheet, or would you rather manipulate your data in ARC? Do you know, what data sets do you have? How clean is it? Things like that. And so my point at this point is like making the map and actually making your maps look beautiful, particularly for your story maps, is, again, at least 40% of that is on the front end, and it's managing your data. Okay. So we're going to stop there for today. You all have lots and lots of stuff to work on for me. And you have lots of stuff to think about. So you can do that however it helps you to do that most. And then, yeah, just get your stuff in, holler at me if you have any questions. And besides that, does anybody have any questions for the rest of the day? Anything right now? Okay. Remember, we don't have class on Tuesday. Again, that's because it's election day. I'm around though. So I'm hoping that you guys are using that time to work on other assignments, and obviously to go vote and heal yourself in whatever way that you need to. That's the most important thing. But you can holler at me if you have any questions. Be on the lookout for an email about class next Tuesday. I'm actually in Louisiana over Veterans Day weekend, so I'm not sure if I'm going to still be there on Tuesday, and if I'm just going to show up and creep everybody out in the lab, or if I'm going to be back here, or where I'm going to be teaching from. So just keep your eyes on your email, and then and I'll let everybody know kind of what's going on, because I'm still trying to figure out what's going on. So, okay. Oh, you don't have a link yet for map assignment 2? These are the kind of questions that I need. These are the kind of questions that I need. I guess if you're asking, we probably don't. Yeah. Okay. I thought you already had it posted. I'll put it up right now. Okay. How did you guys get map assignment 2? How did they give it to you? Yeah, if you don't have map, like, where did I give you these? Can you not even see it? Here. Hang on, I'm just looking. I thought I gave you a Word document. Okay. I made a Word. No, this is old. How do you guys have map assignment 2? Where did I put it? Why can't I find anything? You guys have your map assignment 2, right?
I did it this morning.
Huh?
Oh, sorry. I didn't realize I was muted. I checked this morning and I did not see it. Yeah, I don't have it. in the map assignments thing.
How did I give it to you in the first place?
You have a tab in Moodle that usually holds them. I don't see the second one at all though.
Yeah, but how did I even give you the assignment?
You had said we were gonna have it, but
Did I
we
just
were
like
never
post, did I
given
just
it.
show it to you in class and then was like, cha la, like, and so nobody's really looked on it yet? Yeah, no. No, this map assignment too, this is not it's not here. So it's not, because that map assignment too, this one is spring. Yeah, it's not here yet. So nobody's stressing too much about it right now. I'm gonna put it up right now. We're gonna end and I'm gonna put it, it'll be in this map assignment too.
And is that
section.
November 7th, 8th? The
Yeah,
day we're shooting for still? Okay.
I believe so.
It's next
Oh.
Thursday.
No, it's not. It should be Friday next week.
Okay.
Friday next week. So I'm going in between lab assignment. I'm going in between Google Drive and Moodle. And I think you guys can all tell which one I prefer. So I'm going to go ahead and put that up. So this will be due the Friday after next. I'm going to fix this right now and it'll be there. Okay. All right. Thanks for bringing
Sounds
that
good. Thank you.
up. Bye, guys.